Combining radicals and simplifying. In this video, we're going to focus on combining radicals. Before we talk about how to combine radicals, I want to review what we have learned before, how to combine like terms. For example, if we have 2x plus 3y, or we have 2x plus 3x, or maybe 2y plus 3y, we are able to combine like terms. What do we mean by like terms? For example, x and x, they are like terms. The numbers in front of them could be different because 2x just means we have 2 copies of x, say x and x. 3x means we have 3 copies of x, 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 x. And so in other words, they're all the same thing. So I can draw a graph to show that. So for example, 2x means 1 copy of x, 2 copies of x. 3x means 1 copy of x, 2 copies of x, 3 copies of x. And that's why we call them like terms. And the number in front of the variable just indicates how many of x we have. And since that we have 2x or 3x, we all have x. Put them together, we're gonna get 5 copies of x. So the answer is 5x. Similarly, 2y means we got 2 copies of y and 3 copies of y. Together we have 5 copies of y. But we cannot combine 2x and 3y. You can leave it as it is. 2x plus 3y will still be 2x plus 3y. Or you can just say can't be combined because they're not like terms. Again, if we draw a graph, 2x means we got 2 copies of x, but 3y means we have 3 copies of y. Of course, 2 copies of x and 3 copies of y cannot be combined to get 5 copies of anything. So we're going to specify because they are not like terms. So this is what we learned before. In order to add variables, they must be the same variable, the same thing, that we call them like terms. So similarly, combining radicals, you must have the same radical. For example, we could have 2 radical of 3 plus maybe 5 radical of 3, and radical 3 and radical 3. So that we treat the radicals like a variable. You can think of this radical 3 as an x. So it's kind of like do 2x plus 5x. This radical 3 here, they are the same. We can use the same variable to represent square root of x, and that gives us 7x. Similarly, 2 radical 3 plus 5 radical 3, we're going to get 7 radical 3. Again, the meaning is 2 radical 3 means 2 times radical 3, or you can say 2 copies of radical 3 plus 5 copies of radical 3, we got 7 copies of radical 3. The multiplication sign can be omitted. And similarly, if we have another one, let's say we could have cube root. Say we have 2 cube root of 5 plus 3 cube root of 5, and then we're going to get 5 cube root of 5. So all we have to do is to treat this radical as a variable x, as long as they're the same thing, and we can just combine it. 2 copies of this plus 3 copies of something, you get 5 copies of something. And notice that when we combine like terms, the variable doesn't change. We only add the numbers in front of them. 2 plus 3 is 5. And 5 copies of what? 5 copies of x. So we put 5x. So the variable x doesn't change. Don't get 5x squared. That is not addition. That's multiplication. And just a side note here, x times x would give us x squared. But x plus x still gives us x. It's 2 copies of x. So that 2 is goes in front of x, indicating 2 copies of x. But x times x, that 2 is raised as the square of x. So make sure you know the difference between them. Okay, so go back to combining radicals. What if we have 2 copies of square root of 3 plus 4 copies of cube root of 3? Can we combine them? No, because they are not the same radical. Although they look very similar, but this one is square root of 3, but that one is cube root of 3, and they are still not the same radical, which means they cannot be combined. So you can just say cannot be combined because they're not the same radical. And the same reason as they're not like terms. Because if you're going to use a variable to represent this radical 3, that's square root of 3, but cube root of 3 is a different radical, you're going to have to use y. So it's like adding 2x plus 3 plus 4y, and 2 copies of x plus 4 copies of y, you can't get anything. So that's the same idea. Okay. Next, so we can look at example. Example 1. We are going to, let's say, add maybe 2 square root of 45 over 3 plus, say, 3 square root of 20 over 5, and we can do a minus. To do a similar example, as the homework, I'm going to put a minus here. So we are going to combine, or you can say add or subtract these radicals. As we mentioned before, if those radicals are not the same, they cannot be combined, just like we cannot combine like terms. So first thing we want to look at is those radicals. So we got square root of 45, square root of 20, and square root of 80. They are not like terms. But notice that none of them is simplified. So although at this moment they look different, we cannot combine them. We may be able to reduce them, we simplify them to the same radical. And so first thing we want to do is to reduce simplify each radical here. So we're going to work out here. And this part you can do it on your scratch paper, because this is something we've discussed in the previous sections. So square root of 45, we are going to factor 45. So there are 2 ways to do it. The quick way is, if you can see 45 contains a factor, a perfect square, 9 in there, that would be much quicker. So you get 45 as 9 times 5, and the square root of 9, so it's like doing square root of 9 times square root of 5. Apparently, square root of 9 is equal to 3. We got 3 square root of 5. The other way is, if you cannot see that 9 is as a factor of 45, you just have to break it all the way down as 3 times 3 times 5. And then 2 copies of 3 can be taken out of the radical sign to get a single copy. Because again, the meaning of square root is asking it's 2 copies of which number. Apparently, that's 2 copies of 3. So we write down the number 3 here, a single copy of 3. Again, when you take 2 copies out of the radical sign, you're going to get a single copy. So either way, you're going to get the same answer, 3 square root of 5. Now, similarly, we can work out the other 2 radicals. So before we do anything, we have to check whether those radicals are reduced or not. So let's work on square root 20. Similarly, if we do the quicker way, we can see that square root 20 contains a perfect square 4. So, and the square root of 4 is 2. And square root of 5 is square root of 5, because 5 is not a perfect square. And similarly, for 80, If you can see that 80 is 16 times 5, that would be great. If you can't, you're going to have to break it all the way down and take out 2 copies of it numbers. So here I'm just going to do the quick way. So square root of AD equals 16 times 5, and the square root of 16 is 4. So we got 4 square root of 5. So now what I'm going to do next is to replace all these radicals. So by the way, all the other fractions don't change. For example, there's a negative 2/3. They will stay the same, but when they see this radical 45, because square root of 45 can be simplified to 3 times square root of 5. And then move on to the next fraction, 3/5. And for square root of 20, we know that square root of 20 can be simplified as 2 times square root of 5. And next one is minus 7/2. And the square root of 80 is 4 times square root of 5. So we got the answers from here. Again, this part you can be done on the scratch paper. Okay, now the next thing we want to do is to combine like terms. As you can see, we got radical 5, radical 5, radical 5. So they are all like terms, which means they can be combined. But when we combine them, notice we have a bunch of fractions. And so it may not be as easy as combining 2 copies of some radical 3 plus 2 copies of these 2 examples we did here, 2 radical 3 plus 5 radical 3. But the idea is the same. We are only going to add or subtract the numbers in front of them. See, 2 plus 3. The variable doesn't change. So similarly, the variable is not gonna, we don't have variable. What we have is the radical. The radical is not gonna change. Radical 5, radical 5. All we have to do is to work on the numbers in front of them. So notice that in this case, they can be reduced. If it's like the first one, this 3 and the 3 can be reduced, you can go ahead and do that. And there's a 2 and a 4 that can be reduced to get a 2 here. But the second one, there's nothing to reduce. So in that case, so we can still write down the simplified version, which is negative 2 square root of 5 plus 6/5 square root of 5 minus 7 times 2, which is 14 square root of 5. And now when we combine like terms, again, remember we don't have to change the variable or the radical 5. Treat the radical 5 as a variable. We just need to add or subtract the numbers in front of them. So this is like doing negative 2 plus 6/5 minus 14. When you get the answer, and you just attach that square root of 5 in the end. Okay, so now let's work out the fraction part. Notice that so for the fractions, we have to get the same denominator. So we're going to put 1 and 1 here, and multiply by 5, because the least common denominator is 5. So times it by 5 here, times by 5 here. So we got a common denominator of 5. On the top, we have negative 10 plus 6 minus 14 times 5 gives us 70. And then there's a times square root of 5. So we simplify the top. Negative 10 plus 6, negative 4. Negative 4 minus 7, we got negative 74. And times square root of 5. By the way, square root of 5, you can put it right next to the fraction or put it on the top. So the other way to write it, you can certainly do this. Put square root of 5 right next to it. Usually we would like to move the minus sign and put it in front of the whole fraction. So you could do this. And so it's negative 74/5 times square root of 5 as the answer. So to summarize the steps, step 1, we simplify the radicals if it's possible. And second step is to combine the numbers in front of them. So again, just treat square root of 5 as a variable. Only add or subtract numbers in front of them.